morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Civil Engineering Department from Institute of Aeronautical Engineering. Today our topic is Physical and Chemical Modification. As a part of ground improvement techniques, we have to modify the soil properties and the soil conditions as per the required project. So for getting the desired properties of the soil conditions, we are going to modify in various parameters. Hydraulic modification and different kinds of hydraulic modification, mechanical modification. As a part of that, these physical and chemical modifications are also we are going to consider for the soil modification in various point of view for getting the desired properties based on the requirement of the project. So in these ground improvement techniques, these physical and chemical modification, we are going to support the soil for structures as well as the various infrastructure projects. So in this, we are going to understand the enhancement of the physical and chemical properties. So coming to the physical modification techniques, these physical modification techniques, it is focused on altering the soil physical properties. So we have soil in different types of properties, physical properties. So in this, we are going to enhance or improve the physical properties of the soil. Those are like strength, stability and load bearing capacity of the soil. So in these, some of the key methods include compaction, soil reinforcement and drainage improvement comes under these physical modification techniques. Coming to the compaction, it is the process. So we know, so whenever the dense and loose soil is there, so we are going to densify soil by reducing the air voids through mechanical means. So in this compaction, it is a process densifying the soil by reducing air voids through mechanical means. So the primary goal is to increase the soil density, which in turn enhances its load bearing capacity and stability while reducing its compressibility and permeability. So in this, its load bearing capacity and stability while reducing its compressibility and permeability. Coming to these methods, for compaction, we have different kinds of method for compacting or densifying the soil by using various compaction methods. Static compaction, it is the one of the method where we are using, this is also important, and which kind of desired compaction is required. These are all the depend parameter for choosing the compaction method. So the one is the static compaction uses heavy rollers or static weights to apply pressure to the soil. So effective in coastal soils where slow application of pressure allows for better compaction. So based on the Trajan's theory of consolidation, which describes how this soil compresses over time under load. So in this static compaction, we have to understand whenever the slow application of pressure allows for better compaction is one of the parameter, and it describes how soil compresses over the load. Now next, move on to the dynamic compaction. It involves dropping heavy weights from height to compact the soil dynamically. So static compaction, coming to the dynamic compaction, here it involves very dynamically and dropping the heavy weights from the required height to get the compaction of the soil. So these are applicable to variety of the soil types, particularly granular soils. Relies on the concept of shock waves propagating through the soil to rearrange the particles into a denser configuration. These comes under dynamic compaction method. Now next, move on to the vibratory compaction. Uses vibratory rollers or plates to induce vibration into the soil, facilitating particle rearrangement. So, most effective in granular soils where vibration helps to reduce voids and increase density. Based on the principle of cyclic loading, which describes how repeated loading and unloading can lead to the soil densification. So, in this, we have to understand the vibratory compaction effective in the granular soils where vibration helps to reduce the voids, increase its density, and it depends upon the principle of cyclic loading. So, this is the one of the compaction method. So, based on these, we have to understand the parameters. So, what are the parameters which we are going to understand in this modification are compaction energy, whenever we are applied energy per unit volume, crucial for achieving desired density. So, now moving to the moisture content, optimal moisture content is critical as it influences soil plasticity and compaction efficiency. In this soil plasticity, so whenever reduce the plasticity, it increases the soil strength. So it depends upon the how much moisture content is required for the soil property as a soil property. It depends upon the which type of construction work is going, and furtherly we have to understand we are going to do the design of the infrastructure or the whatever the structure we are going to construct in that particular region. So, this soil types, different types of soil types are there. So, each kind of soil type has its own kind of respond uniquely to these compaction effects. So, clayey soils, we are applying the static method. It reacts in different, the reaction is different when compared to the dynamic method we are using for the compaction. So, same kind of soil type is also which type of method we are choosing, this gives the desired different properties. In that, which one is desired property for the project which we are going to choose. So, in this soil type, different types of soils respond uniquely to compaction efforts. It depends. Coming to the soil reinforcement. This soil reinforcement involves the addition of materials with high tensile strength to the soil improve its mechanical properties. So, the reinforcement material works by the carrying tensile loads and distributing stresses more effectively within the soil. So, these methods and theories comes under the soil reinforcement, geotextiles and geogrids. Geotextiles are permeable fabrics that allow water to pass through while providing tensile strength. So, in this, they are going to allow while providing the tensile strength is the property. In these, geogrids are grid-like structures that interlock with soil properties providing additional stability. So, these are the methods which we are used for the soil reinforcement conditions. Whenever we required the tensile strength, we are choosing the geotextiles methods. Coming to the additional stability is required, we are choosing these grid like structures, those are going to interlock the soil particles. Based on the theory of the reinforced earth, where the combination of soil as well as the reinforcement creates a composite material with improved properties. So, whenever the soil, loose soil is available, we are using these kind of reinforcement grids or textiles, whatever it we are going to use, or some mesh like some concrete may we may pour. And these kind of, whenever water is going to there and any kind of rivers, whenever the landsliding is happened, so whenever the landslides are occurred, so for the retaining walls and all the, whenever the soil is loose and the dense, so such type we are going to prefer these soil reinforcement for getting the desired properties of the structure. So, based on this earth force, we are going to improve some stability as well as the strength point of view. Coming to the soil naming, it involves inserting steel bars into a slope or excavation to stabilize it. So nails are installed at regular intervals and angles to create a composite mesh that resists shear and tensile forces. So this theory relies on the concept of passive resistance where the nails provide anchorage and improve overall stability. So reinforced earth combines soil with materials such as metal strips or geogrids. The reinforced soil mass acts like coherent block with improved shear strength and reduced deformation. The theory is based on the Columbus earth pressure theory, which describes how reinforced material interact with the soil to resist loading. In these parameters, reinforcement type, spacing and orientation, soil reinforcement, interaction. So these are the three important parameters which we are going to choose which type of method. So based on the reinforcement type, choice of geotextiles, geogrids or metal strips based on the project requirement of the desired properties of the soil. How it leads? Soil desired properties. Coming to the spacing and orientation, proper placement and orientation, it maximizes the effectiveness. So this soil reinforcement interaction assuring adequate bonding and interaction between soil and reinforcement materials. So now we have to understand this drainage improvement. So improving soil drainage involves removing excess water to enhance soil stability and strength. Proper drainage reduces the pore water, thereby increasing effective stress and improving the soil bearing capacity, that load bearing capacity of the soils. In these also involve various methods and theories. Vertical drains, sand drains, dewatering are the various methods which are going to involve. So which one we are chosen is also depends upon the summer based on the parameters. So in these vertical drains, prefabricated vertical drains, PVDs or wing drains are installed to accelerate the consolidation process by providing a shorter drainage path. The theory is based on the consolidation theory, which describes how soil settles over time as pore water is expelled under loading. So we have to understand the how the soil is going to settle over the time to time as pore water is expelled under the loading conditions. Coming to the sand drains, sand filled columns that facilitate vertical drainage in soft soils. In these, the principle which is involved is the increasing the permeability of the soil, that thus accelerating consolidation and the settlement. In this dewatering, finally we are going to reduce the water content and we are going to move towards the how much water content is required, whatever the excess is there, we are going to removing in that modification technique. So that is the one of the thing is the dewatering involves pumping out of the groundwater to lower water table and reduce the pore water pressure. So utilize this principle hydrostatics and flow through porous media to manage groundwater levels effectively. In this parameter for choosing the method is the drainage path length, drainage material, permeability are the major parameters which we are going to understand in this modification. So in this drainage path, shorter drainage path results in faster consolidation. So drainage material, selection of materials like sand, geotextiles, synthetic products based on the soil conditions. Permeability, high permeability soil facilitate quicker drainage and consolidation. These are the parameters which we are going to understand in this physical modification. So till now we are understanding the physical modifications for getting the desired soil properties as per the required project, and based on all these various methods we are going to choose based on the parameters and required based on the desired properties, where we are going to get the enhanced load bearing capacity and stability. So all these various soil properties we are going to understand. Now move on to the chemical modification techniques. So it is altering chemical composition of the soil. So till now we are altering the physical properties of the soil. Now coming to these chemical modification techniques, we are going to improve engineering properties. This method significantly change soil's physical and chemical characteristics. In this, the one is the soil stabilization. It involves addition of stabilizing agents. Because of these agents, these modifications are known as chemical modifications. So to soil enhance its properties such as strength, durability, resistance to water, the stabilizers react with soil minerals, forming new compounds that bind soil particles together. So in these different various methods and theories are involved for this stabilization. The one is lime stabilization, cement stabilization, bitumen stabilization. So in this, coming to the lime, that is nothing but the calcium oxide is added to the clayey soils. Here also we have to understand what type of soil it is and what are the parameters are desired, what are the required parameters for the project, and how we will get which type of, and what method is better for getting the desired required property is the thing we have to understand. So like this we have to understand, and we are going to choose the method for getting the modification of the soil depends upon the various parameters, and what are the desired and what are the various parameters for getting the optimal solution of that particular modification point of view. In this, lime is added to clayey soils which reacts with soils, silica and alumina to form cementitious properties. So this process is known as pozzolanic reaction, improves soil workability and its strength. So what are the properties are going to enhance the properties based on the requirements for choosing the method. So in this process we have to know the process gives the pozzolanic reaction. Based on this pozzolanic chemistry and soil mechanics, based on those principles we are going to understand and we are going to choose the suitable method. Now cement stabilization. So mixing cement with soil forms a hardened mass that significantly increases its strength as well as durability. So the hydration reaction of the cement with water creates CSH, calcium, silicate, hydrate and calcium aluminate hydrate compounds that bind soil particles. So relies on the principle of cement chemistry and soil cement reaction. Coming to the bitumen stabilization, uses bitumen to coat soil particles, making the soil more resistant to water. So the bitumen acts as a bender, reducing soil permeability and improving its load bearing capacity. Soil permeability, reducing soil bearing capacity and improving its load bearing capacity. Based on the principles of asphalt technology and soil bitumen interaction. So these are the methods. So for choosing these methods, we have to understand some of the parameters. Those are stabilizer type and how much percentage of the dosage is also plays a role in chemical modification. So in this mixing method, curing time are the parameters. So these stabilizer type and dosage choose and amount of stabilizing agent based on the soil type and desired properties. In this mixing method, ensuring through a mixing of a stabilizer with soil for uniformity. So based on that uniformity. In this curing time, allowing adequate time for chemical reactions to complete and achieve desired soil improvements. Coming to these grouting, it involves injecting fluid-like materials into the soil to fill voids and improve its mechanical properties. So the grout hardens within the soil, creating a soil mass that enhances the strength and stability. In these also methods and theories are there. In these permeation grouting, compaction grouting, jet grouting comes under these chemical modifications. So these permeation grouting is inject into the soil without disturbing its structure, filling the pore spaces. Important parameter is without disturbing its structure. It is suitable for granular soils with high permeability. So based on the Darcy's law of fluid flow through porous media and the principles of soil stabilization. Coming to the compaction grouting, a stiff grout mixture is injected to displace and compact the surrounding soil. So effective in soils with low permeability and voids. Relies on the principle of soil mechanics and the compaction theory. Coming to the jet grouting, high pressure jets mix grout with soil inside and creating columns of grouting soil. Suitable for variety of different types of soil types and their applications based on the principle of high pressure fluid dynamics and soil grout interaction. Coming to the parameters, grout type, injection pressure, grout volume. These are the parameters for are depending on this modification. Coming to the grout type, selection of cementitious, chemical or resin grouts based on the project needs. Coming to the injection pressure, pressure at which grout is injected to ensure adequate penetration and filling of voids. Coming to the grout volume, amount of grout required to achieve desired soil improvements. Coming to the chemical injection involves injecting the chemicals into the soil to improve its properties. This chemical reacts with soil minerals. This is the important parameter. Chemical have its own properties and it has its own kind of minerals within it. They are going to involve with soil minerals, creating compounds to enhance the soil strength, reduce permeability and increase the resistance to the erosion. In this, coming to the method, silicate injection, polymer injection and enzyme stabilization. Coming to the silicate injection, silicate based solutions are injected into the soil where they react to form gels that solidify the soil and effective in stabilizing loose and sandy soils. For this type of soil is for stabilizing, getting the effectiveness in loose and sandy soils based on the principles of chemical soil stabilization and silicate chemistry based on the principle. Coming to the polymer injection, the polymers are injected to bind soil particles, creating a cohesive mass that reduces permeability and increases strength. It is suitable for variety of soils, particularly in erosion control. Based on the polymer chemistry and soil polymer interaction. Coming to the enzyme stabilization, enzymes catalyze chemical reactions within the soil, enhancing its properties, effective in improving soil workability and reducing plasticity. Based on the soil enzyme interaction and biochemical principles. In these parameter, chemical type and concentration, injection technique, reaction times are the parameters. Coming to the chemical and concentration, choice and concentration of chemical based on the soil type and desired properties. Coming to the injection technique, method of injection chemicals to ensure uniform distribution and reaction. Time required for chemical reaction to achieve desired soil improvements. These are the some of the web references we are going to understand for the physical and chemical modifications. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.